Okay, welcome again, and this is the video about the Excel application for engineering optimizations, and this is an example taken from the water resource system techniques book called Vedula, and this help us to go through and see how one can come up with the linear equations and do the linear programming analysis in Excel. So this example said that two crops are grown on a land of 200 hectares, which means you have to see that the land is limited to 200 hectares, and the cost of raising crop 1 is 3 units per hectare, and the cost of growing crop 2 is 1 unit per hectare, and the benefits from crop 1 is 5 units per hectare, and from crop 2 is 2 units per hectare, and the total amount of money available is only 300 units, and for raising both crops. And the question is, what should be the cropping plan? So how much area will go to the crop 1 and how much area will go to crop 2, so that we can obtain the maximum benefit. So if we formulate a problem first, so they say, like for example, if you have a crop 1 and crop 2, okay, and let's say the area of crop 1, let's represent the area which is being covered by crop 1 as x, and the area which is being covered by crop 2 as y. So we have seen that cost wise per unit area or hectare per unit in units per hectare, for example, for crop 1, how much is it? For crop 1 it is 3 units per hectare. The cost is, for crop 2 it is 1 unit per hectare, which means in units per hectare for crop 1 it is 3, for crop 2 it is 1. And the benefits, okay, in units per hectare. Okay, unit per hectare, units represents the money. So in this case also we have 5 units per hectare from crop 1 and 2 units per hectare from crop 2. So this is 5 and this is 2. And then what you can see again is the money available. Okay, money available, and it is 300, okay, and the land available, it is 200 hectares. This is 300 units, 300 units of money, and 200 hectares of land. So now this is the cost per unit area. So total cost, if you want to find total cost, so the total cost in whatever you call it, units can be birr, dollar, or pound, whatever it is. So you have area, you have the cost per unit area. So if you this area is given in hectare, so if you multiply area by the cost, which means hectare will go by hectares, then we have the total cost of the crop. So which means the total cost of crop 1 goes to be 3x, okay? And the total cost of crop 2 is going to be y. 1 times y is y. So, and total benefits, okay, total benefits in units. So the total benefit will be, this is the benefit that we can obtain from a 1 hectare for crop 1, and this is a benefit that we can obtain from 1 hectare for crop 2. So if we multiply this by the area, which we will get the total benefit. So this means it is 5x 5x, and this is 2y. Now from this one we can create our conditions or our problem. So now formulate the problem. Okay, now our objective function, the objective function will be d. Okay, let's say d is our objective function. So what is z? Z should actually be equal to the objective function. Z should be equal to, so our objective is to maximize the benefit. So the total benefit is how much? From crop 1 it is 5x, from crop 2 it is 2y. So the benefit is 5x plus 2y. So this is the total benefit. But there are constraints. Okay, there are constraints. So what are the constraints? One, the land is limited. So what is the total area we have? For crop 1 we have area x, for crop 2 we have area y. So total area, if you want to get the total area, it should be x plus y, right? Then but we have limited area, which is only 200 hectares. So x plus y should be less than or equal to 200 hectares. Okay, and again you can look at the money available. So the crops are going to cost 5x, 3x, and y amount of monies, and the only money you have is 300. So the cost of crop 1 and the cost of crop 2 should be less than or equal to this one. So we can create that 3x, which is the cost of crop 1, plus y, cost of crop 2, should be less than or equal to 300. This is one. And the other thing is that x and y are positive values, because they are area cannot be negative, which means whatever you do, x should be greater than or equal to 0, and y should be greater than or equal to 0. So this is the conditions. Now we can do our analysis and we can create the conditions. So for that we have to write our parameters in terms of volume, in terms of formula. So assume some certain random x and y values. Okay, you have to assume certain random x and y values, which totals to 200. Because the area is 200, so x plus y should be 200. Then if you assume like an area of 124x and 84y, so it totals to 200. Then we'll create the formulas. So z, the total benefits, that is our objective, to maximize the benefits, and to maximize the benefits, so how much area should go to crop 1 and how much area should go to crop 2. So this is equal to 5x plus 2y. So it is 5 times the x value, then plus 2 times the y value. So this totals to 760. So there are constraints. This is the objective function, and the constraints. Okay, constraints are the first is that x plus y. So x plus y means this plus this should be less than or equal to, okay, less than or equal to 200. Yeah, and the second one is that 3x plus y is equal to this should be less than or equal to 300, which is not fulfilling the conditions. At the same time, you have x values, which is x, and x value should be greater than or equal to 0, and this should be y. Okay, the y value should be greater than or equal to 0 again. This is the last constraints. So depending on this one, we can iterate for the best values that we can obtain. So to optimize, we can use solver again. So you go to data and you have a solver, then and now you have to set your objective. So your objective is to maximize this value. Okay, this needs to be a formula. You have to write them in a formula. If you enter a number, it is not going to iterate anything. So this is the objective function, and the objective function needs to be maximized. So it is a benefit, we have to maximize it. If it is about problem, so we have to consider minimizing. If it is error, we have to minimize it. In this case, we are looking for a maximum benefit, so we have to maximize that. So then by changing variables. So in this case, x and y are the important variables, and we just assumed them randomly. We don't know the exact value. So by changing these x and y values, and we need the equation or the solution to be maximum value, then for that you have to enter a constraints. And then to add your constraints, you can just come here and say add. This is the constraint boxes, and then you can say add. So the first constraint is that the x plus y, which means this should be less than or equal to 200, and then say add. And then the additional one is that there's 3x plus y should be less than or equal to 300. Okay, and then say add again. And then this is that the value of y or the value of x should be greater than or equal to 0, and say add. The value of x should be greater than or equal to 0, and say you have inputted all the four constraints, and say okay. So check the dimensions and the values you input here. If they are correct, then once you are done with them, you can use a simplex linear programming. So simplex method, you might come up with this, or you might learn detail about simplex method in water resource systems. So simplex method will do the iterations and solve the equation, the problems you create. So say okay, then you can see the results. So if you have to iterate again, go to solver, and then the same constraints are there, and they solve. Then you can have your outline reports. Okay, you can see the scenarios. Okay, and this is what you get. So this is x is equal to 50 and y is equal to 150, which means these are the optimal values where the objective function is maximized to 550 units, and all the criteria has been met. So this is how we do optimization in Excel.